Hello friends, welcome to my channel. Today let us discuss about 6G workshop which held on 10th and 11th March in Korea. This workshop mainly focused on 6G and it was hosted by Telecommunications Technology Association TTA along with 3GPP individuals. There were around 603 face-to-face participants in that workshop and discussions were covered from radio, core network, protocols, and many more, which we will try to explore in the subsequent slides. 6G motivation or why 6G? So this particular slide is the exact slide which was discussed during 3GPP workshop. If you want to read it, you can pause the video for a while, but I'll be explaining this slide in my own terms in the subsequent slides. What is the motivation behind 6G or why 6G is required? Let us discuss this point by point. Support for new service and use cases. Imagine a world where your device don't just communicate but also understand and sense their environment. 6G aims to integrate communication with advanced sensing capabilities, enabling applications like extended reality, immersive experiences, and AI-driven services. For instance, 6G networks could function as sensors themselves, providing precise localization and environmental data, thereby reducing costs and enhancing functionality. Revenue growth and monetization. Think beyond traditional telecom services. 6G opens up new revenue streams by monetizing advanced network capabilities. Industries can leverage these networks for diverse applications, from smart agriculture to autonomous vehicles, creating opportunities for growth and innovation. AI and automation. Envision networks that think and adapt on their own. 6G is set to be AI native, incorporating artificial intelligence to automate, optimize, and enhance network management and resource allocation. This means more efficient operations and ability to swiftly adapt to changing demands. Spectrum efficiency. Imagine unlocking new frontier in the airwaves. 6G plans to utilize spectrum more efficiently through dynamic sharing and exploring new frequency bands such as terahertz communication to accommodate the ever growing demand for data. Ubiquitous coverage. Picture seamless connectivity no matter where you are. By integrating terrestrial and non-terrestrial networks, example satellite, 6G aims to provide ubiquitous coverage, ensuring resilient services even in remote areas. Energy efficiency and sustainability. Consider a greener planet powered by smarter networks. 6G focuses on reducing energy consumption and promoting environmental sustainability. Features like self-sustaining connectivity, where devices harvest ambient energy, aim to minimize the carbon footprint of network operations. Total cost of ownership reduction. Think smarter spending for better networks. 6G seeks to reduce both capital and operational expenditures through simplified network operations and improved energy efficiency, making advanced connectivity more cost effective. Improved service reliability and customer experience. Envision networks you can always rely on. 6G aims to enhance service reliability and resiliency, leading to superior customer experience with fewer disruptions and more consistent performance. And the last but not least, network simplification. Imagine a network that's powerful yet simple. By reducing complexity and streamlining architecture, 6G intends to improve operational efficiency, making it easier to deploy, manage, and scale network services. In summary, 6G is poised to revolutionize connectivity by introducing advanced capabilities that support new services, drive economic growth, enhance efficiency, and promote sustainability. These advancements aim to create a more connected, intelligent, and efficient world. Lessons learned from 5G. This is one of the important aspect of this 3GPP workshop. But this is the actual slide which was presented in 3GPP workshop. If you want to go through it, you can pause the video. But I have explained this slide in my own words, so stay tuned. Now let us point by point discuss lessons learned from 5G and how we are going to mitigate this in 6G. So first point is about migration challenge. Transition from non-standalone to standalone was very complex. It required significant changes in network architecture and deployment strategies. How we are targeting it to improve in 6G? A streamlined migration approach with a cloud native and software defined core will be used to ensure seamless transitions with minimal complexity. Architectural complexity. A large number of architectural options, features, and configurations had led to high system complexity in 5G, which had impacted UE capabilities and also deployment efficiency. In 6G, a more structured and modular approach focusing on essential configurations is taken, which will eliminate the unnecessary complexities to optimize performance, and it will also reduce deployment overhead. Slow adoption of key capabilities. Features like network slicing in 5G had very slow adoption due to implementation challenges and lack of standardized deployment. But in 6G, from the start, it will incorporate simplified and automated network slicing mechanism. This will ensure easier deployment and faster adoption. Deployment inefficiencies in 5G. Challenges such as NRF profile and suboptimal protocol choices, example HTTP by 2, led to deployment inefficiencies. In 6G, it will refine protocol selection and enhance network resource. Functionality optimization. In 5G, too many feature options and configurations resulted in increased complexity without proportional benefits. 6G will prioritize a well-dimensioned set of functionalities, removing redundancy and excessive configurations to enhance network efficiency. Let us discuss about radio access network or RAN for 6G design considerations. So this is the exact slide which was discussed in 3GPP workshop, but we will be discussing in subsequent slides about these highlighted points, which will be that 6G UEs will be non-backward compatible, 6G will be lean and streamlined, there will be superior coverage for 6G radio from day one, there will be diverse device types supported, and how AI/ML will help in achieving 6G its target. Let us discuss in details. 6G will introduce a new radio interface that won't be compatible with older devices like 5G or earlier phones. Non-backwards compatibility signifies that 6G UEs will not inherently support legacy 5G or earlier network protocols. I know you must be thinking what is the rationale behind this approach. Let us explore this in the subsequent slides. Let us see point by point how this non-backward compatibility of 6G devices will help. So first point is better performance. It means without old limitations or the limitations of the old devices like 5G and 4G, 6G devices can achieve faster speeds, lower delay, and better signal efficiency for higher demand applications. There will be more design freedom. 6G can use new network structures and protocols suited for futuristic technologies like AR, VR, and AI powered systems without worrying about the older standards. spectrum utilization will be efficient. It can fully utilize high frequency bands, including terahertz wave, for ultra fast data transfer and better network capacity. 6G devices can also support advanced communication technology, like it can support next generation waveforms, modulation, and coding for more reliable and stable connections. So, to conclude it, we can say that this non-backward compatibility will result in higher freedom for 6G device design, and the 6G targets for throughput, reliability, as well as latency can be achieved more realistically and without any hindrance or any support for the 5G or 4G technology. Now let us see, if there is no limitation of supporting 4G or 5G technology in 6G devices, what enhancement we can expect in 6G radio or 6G devices. First advancement is for the waveforms. While 5G new radio employs orthogonal frequency division multiplexing or OFDM, 6G is exploring waveforms like OTFS, orthogonal time frequency space. OTFS offers resilience against Doppler effects and multipath fading, which makes it suitable for high mobility scenarios, and this improves communication reliability. Second point is regarding support of higher order modulation schemes. 6G aims to utilize high order QAM schemes such as 1024 QAM and 4096 QAM. How these will be helpful? These schemes increase the number of bits transmitted per symbol, thereby enhancing data throughput. Last point is regarding evolved channel coding techniques. Building upon 5G's adoption of low density parity check or LDPC and polar codes, 6G is expected to refine these coding schemes further. Innovations may include improved LDPC algorithms and advanced polar code constructions to support the ultra reliable high throughput demands of future applications. So these were the few major points where this non-backward compatibility of 6G devices will help in enhancing the 6G device. Now let us see how lean and streamlined 6G will take place. So there are few key aspects for lean and streamlined 6G which can be divided in three parts. First one is 6G will be able to optimize functionalities for specific use cases. It will minimize redundant options, and also it will avoid excessive configurations. Let us see these point one by one. So optimize functionalities point of view, 5G is feature rich, but it is complex. It supports diverse applications like EMBB, URLL, CMMTC. It leads to increased deployment challenges. 6G implements only essential functionalities tailored to different device types and services. It will be cloud native and AI driven design for high efficiency. Instead of one size fits all approach, 6G will provide customized options for ultra low power IoT versus high speed mobile broadband. Redundant options. 5G supports multiple architecture options. Example option 3, 3A, 5, 7 for NSA and SA nodes. While flexible, too many transition paths add complexity for operators. 6G need to eliminate overlapping deployment models, which will ensure a single optimized framework. It aims for a clear, standardized evolution path from day one. A standardized 6G framework will ensure smoother adoption and interoperability. Now the last point, excessive configurations. 5G supports thousands of configurable parameters for optimizing performance across different radio environments. 6G need to reduce the unnecessary parameters, making network deployment and management simpler. It will be done based on AI driven self optimization. So to conclude, we can say 6G RAN will simplify network architecture by removing redundant options and reducing unnecessary configurations. There will be few parameters plus AI driven tuning of the network configurations will result in easier management and improved efficiency. A unified framework from day one will ensure smooth deployment and long-term scalability. Superior coverage for 6G radio from day one. How is it possible to have superior coverage for 6G? That too from day one. Let us see some of the key factors which may help to achieve this in 6G. First point is integration of terrestrial and non-terrestrial network. Combining traditional ground-based infrastructure with satellite systems and high-altitude platforms can extend coverage to remote and undeserved regions. This harmonized approach ensures consistent connectivity across diverse environments. Second point is about advanced beamforming and MIMO technologies. Implementing sophisticated beamforming techniques and MIMO system, it enhances signal strength and quality over greater distance. These technologies focus energy towards specific user or areas, effectively extending coverage and improving the user experience. These technologies are especially used in densely populated urban environment. Third one is the most fascinating of all. It is deployment of intelligent reflecting surfaces. IRS or intelligent reflecting surfaces can be strategically placed to reflect and direct signals around obstacles, mitigating issues like signal blockage and attenuation. This innovation contributes to more consistent and reliable coverage, particularly in complex urban landscapes. Last point is adaptive QoS. Employing technologies such as adaptive quality of service, these frameworks can optimize network performance, ensuring consistent service quality across different coverage areas. 6G may support diverse device types with scalable design. Let us try to understand this. 6G is being designed to support wide variety of devices from the very beginning, unlike previous generations where device capabilities evolved over time. This scalability ensures that different types of devices can efficiently utilize the network based on their specific needs. There are three major aspects to it. First one is bandwidth or data rate. Devices with different data requirements from ultra high speed AR VR headsets to low data IoT sensors will have optimized access to the network. In fact, high bandwidth applications will benefit from new spectrum bands, while low power devices can efficiently operate on minimal bandwidth. So 6G should support the span of all these devices. Form factor. 6G will support various device sizes and designs, including wearables, embedded sensors, smartphones, and even microscopic IoT devices. This flexibility allows for innovation in industries like healthcare, where these can be used as smart implants, smart cities, where embedded sensors can be used, and consumer electronics like wearable displays. Last and important point is about energy consumption. 6G networks will optimize power usage based on the device type. Battery powered IoT sensors will use ultra low power modes, while high performance computing devices can utilize high energy profiles. Energy efficient communication techniques like AI driven power management and optimized signal transmission will help to extend the battery life of these devices. So, we have seen that 6G has to support a diverse range of devices to support n number of use cases. Now, let us discuss the last topic about 6G radio interface, which is AI/ML. Before we move to 6G, let us explore how AI/ML is used in 5G advanced. Although it is still in early stage, but AI/ML is exploited in few of the use cases like RAN traffic prediction, where AI is used to forecast network congestion to optimize resource allocation. Second is energy efficiency optimization, where AI is used to adjust power consumption dynamically based on traffic. And some of the basic network automation are also done using AI, but it still requires human intervention. How 6G will be different? 6G will be fully AI native. So 6G may be using self-learning RAN. It is AI-driven spectrum management and real-time resource allocation without any manual intervention. 6G may also use real-time AI-driven performance monitoring. It will dynamically adjust network parameters based on the changing radio conditions. AI/ML lifecycle management will also happen, like automatic activation, tuning, and deactivation of AI models based on the network conditions. Seamless AI to conventional algorithm and conventional algorithm to AI transition should happen. So the fallback mechanisms when AI based process fail or it needed optimization. By building upon the foundations laid in 5G Advanced, 6G aims to harness the full potential of AI/ML technologies, enabling innovative use cases and enhancing overall network performance. Thank you for watching the video. If you have reached till the end, there were few more aspects which were discussed during the 3GPP workshop, like core studies and transport aspects were also discussed. Timeline for 6G was also discussed. So for the sake of time, I will not be discussing these details in this particular video, but I will put them as short videos in my subsequent videos coming up on the channel. So thank you for watching. If you have any particular topic on mind which you want to me to discuss and explore in the videos, please do let me know in the comment section. Thank you.